information product information will be stored in the form of columns, where whatever ratings you have given about this product will be stored in the number form, like 2 stars, 3 stars, 4 stars, 5 stars. So these are all at the back end, these are all stored in a matrix form to analyze the information at the later part. So this is how matrix are used in product rating and image storage. So this is where actually matrix will used. And uh, let's see the real time applications. First um, ma- uh, first application is facial recognition. In this, when your phone unlocks by scanning your face, it converts your face into numbers inside a matrix. That is how matrix will be converted your face into numbers, and later part that will be um, check if it is you or not. In this, first step is a camera takes a photo of yours and convert it into a grid or matrix forms in terms of rows and columns. One of the column or row represents the values which are known by brightness values, and AI extracts the spatial features using matrix operation, and it compares with saved matrices. It compares with the saved matrices to check if it's you or not. If the new matrix, again, you if you want to unlock your phone, if that face got captured, if the new matrix is similar to the saved one, your face got unlocked. All this happens in milliseconds using matrix math. This is how facial recognition applications are work. And the um, other applications are recommendation systems. So in recommendation systems, usually if you watch any movie in Netflix or YouTube, uh, the complete information, like how much time you have watched, and uh, user information, and what ratings you have given to that movie, everything got stored in a matrix form at the initial level. Later part, if you log in into Netflix app or YouTube, so that will suggest what kind of movies you can watch. That information that will predict and provide it to you according to your taste and interest. This is how recommendation systems uses matrix to give suggestions for the users. And the third one is search engines. If you want to browse any information in any of the search engines, like for example, if you take a Google browser, there if you want to search any information, first Google tracks how websites are linked using matrices, and it decides which pages it has to show up first. Like usually in the during these days, if you search any information in Google, the first link is AI recommended link, and the later part it is showing some other links related to the content you have searched. This is how matrix decide which pages show up first in search engines. So these are all the real time applications. Let's see a case study. Like um, um, like uh, like if you take a school cafeteria, imagine a school cafeteria consists of I mean students, which are placed in rows, and columns are food items. If a students like a food, we give it a high score like 9 by 10, and if they don't, so they will give a low score like a 2 by 10. This table of preferences is like a matrix. In the same way, AI uses matrices to understand people choices and predict information and act accordingly. So this is all about matrix. Let's work on simple examples. The first example is face unlock system. Let's take a problem. Suppose a face at the initial stage, a face image is stored in a 2 by 2 matrix. It's an example. Actually, face image will be stored with a uh, multiple rows and multiple columns. So here we'll take an example of 2 by 2 matrix. There your face is stored in a matrix form. Each pixel brightness shows a number form here. The 10 represents a pixel brightness and 20 element represents another pixel brightness. This is how matrix will store your face, and another image is captured for comparison. This is new image that will be stored like this. Each pixel's brightness will be stored in the stored like this. So if we subtract by using math formulas, if we subtract both matrices to compare, the result will be 0, -1, 0, and 40 minus 39, 1. So the total difference, if we calculate here, it will be 0 plus -1 plus 0 plus 1, that is equals to 0. So which is e- equal to the image captured at the first level. So AI suggests unlock the phone. So this is how math calculations will work to unlock a phone. And let's see in another example to filter an image. Like if we take an image matrix, for example, it's 255 pixel, 180 pixels, 100 pixels, and 50 pixels. So, by applying brightness reduction filter matrix, let's say if you want to reduce 20 pixels from this first element and another 20 pixels from second element and 20 pixels from each of the elements in the first matrix. So, if you want to reduce the brightness of the original matrix, you're using a brightness reduction matrix by applying a formula like A plus F. The pixel number got reduced to 55 minus 20 to 35, 180 minus 20, 160, 100 minus 20, 80, and 50 minus 20, 30. So this is how AI reduced brightness of each pixel. This is how filters works in AI applications. So these are the basic examples of face unlocking system and filtering an image. So let's see another topic in linear algebra and calculus, that is eigenvalues and eigenvectors. So these are also special parts of matrix that help AI focus on important information like eigenvalues and eigenvectors. Basically, working on if we work on big data analysis, we use these eigenvalues and eigenvectors formula. So here eigenvectors shows the most important direction or feature in a data. So if we have, for example, if you take a face pixels, it has 10,000 pixels. In the eigenvectors shows, will take special features like distance between eyes or size of the nose. In that way, it will take a few features. So here, by taking two features, eigenvalues show how strong or important that feature is. It will decide. In simple words, they help AI ignores less important details and keep only what's necessary. So it will not take other parts of your face information, just focusing on main features like eigenvectors will show the direction which are more important for predicting a face. The first thing is eyes, the other thing is nose. So eigenvalue will give the distance between eyes and the length of a nose. So these two values will take into consideration for doing any kind of applications, like if you take image compression, if you want to recognize a face, and if you want to give any suggestions, if you want to analyze image processing information. So for any kind of applications, just it takes important information and ignores the rest of the information. So eigenvalues and eigenvectors are preferred to find out which features are more important and what are the values which has to be taken into consideration to analyze the data. So this is how eigenvalues and eigenvectors are used. So let's see the applications. Like earlier I discussed, eigenvalues or eigenvectors are used for image compression. Like if you take photos, Google Photos uses eigenvectors to keep your photo quality same while using less storage. So it will compress your photo and store important features in your photo for later part of usage. Like if you want to retrieve, it will find out those features and retrieve it uh, from the application. So this is how image compression will work. So it will take your image, and it will preserve quality, and it will the main benefit is to using it for lesser storage. And then the other one is face recognition. So AI looks at key face features, as I said earlier, like the distance between your eyes or the shape of your nose. By seeing these features only, it will recognize the face. And the thing is, recommendation systems like AI finds what type of content you like by reducing data to only important features. That is discussed in the previous matrix example, like Netflix and Amazon use these concepts to identify patterns in user preference. So finding the directions that best explain what kind of movies or products people like. So this is how eigenvalues or eigenvectors are working back at to give these AI applications. So let's discuss a case study like Google Photos face grouping. Um, So here AI finds facial features matrix of pixel values, applies principal component analysis that we'll discuss in when we are discussing about when we are working on eigenvalues and eigenvectors problem, that is called principal component analysis. Google Photos grouping similar faces using principal component analysis, which is based on eigenvalues or eigenvectors. AI finds facial features and applies PCA to get eigenfaces, reduces the image size from 1000 pixels to just 50 to 100 values, and groups photos with similar eigenfaces. These are all, I mean, executing by AI using eigenvalues and eigenvectors formulas. Let's see a case study. If we take a school photo or a school play or spotlight, imagine a school play. Many students are on stage, but the spotlight is on only on the main actor. The spotlight's direction is like an eigenvector. It points to what matters, what actually required, and the brightness is the eigenvalue. It shows how important that part is. So AI does the same, focusing only on important data I mean, um, reducing the focus on the rest of the data. So this is how AI works with eigenvalues and eigenvectors. Let's see some examples.